Welcome to Data Skeptic Machine Intelligence, our podcast series exploring contemporary topics in artificial general intelligence and large language models. It seems like just about every day there's a new use case, startup, paper, or project that's applying large language models in some hopefully interesting and novel new way. And not just for the obvious things like summarize these bullets into an email, or convert this document from the police station into some news article. Paradoxically, the limits of ChatGPT might be the human imagination. In any event, today we explore one application of these tools in the social science space. If you want to conduct academic research about something, let's say political viewpoint, you've got to gather data somehow. Sometimes that means interviews, which are expensive and difficult, although maybe they can be done online. Or maybe we can crawl some data from social media. Get things like Twitter posts and use them in our analysis. We can make it easier and easier to maximize the value we get out of our human subjects. Can we get to a point where we still even need those human subjects? That's one of the questions we dig into today. When human experts, mechanical Turkers, and ChatGPT are all put to the same test, who comes out on top?
My name is Petter Tarnberg, and I'm an assistant professor in computational social science at the University of Amsterdam. I'm also senior researcher at the University of Neuchâtel and also associate professor at Chalmers University in Sweden.
Can you tell us a little bit about what's under the umbrella of your academic interests?
I have kind of a funny academic trajectory to a certain degree because I started with my bachelor. I studied computer science, and then I shifted over to physics for my master's, studying complex adaptive systems. And from there, I kind of moved into the social sciences. First, I was working in sociology for a couple of years as a postdoc, and then I actually moved over to geography. And then now I've kind of moved back to the roots to a certain degree by going to computational social science and being embedded at the ILLC, which is mostly computer science department. But my work throughout this time has been focused on the intersection between computational methods and their meaning and application in the social sciences. I'm especially interested in the sort of questions of epistemology. What does it mean to apply these methods, and what does it capture of the social world? I'm really not on the sort of bleeding edge of the technological aspects anymore, but more focused on the social scientific theory and those more theoretical questions around new computational methods and new forms of data.
Well, depending on how you tell the story of history, computer science is a pretty new discipline. And then by definition, computational social science has to be even newer than that. How mature is the field from your point of view?
I'm actually part of developing the first bachelor program in Europe in computational social science. So I'm getting to be part of this really exciting journey of trying to define a discipline, which is kind of part of the job of developing a new program. And I would say it's very much kind of in the process of emerging. So it's not very, there's still kind of important splits, I would say, in the discipline where there is this very computer science focused, in some ways, I would say, reductionist approach to understanding the social world, where we don't need theory anymore. It's enough to just have great data and good models, and we can kind of throw out all the old knowledge. I've written a paper about this, presenting this notion of a heterodox computational social science. So drawing the sort of parallel between neoclassical economics in the 90s and so on versus heterodox economics in the 90s, where the neoclassical economics was very much connected to certain political streams and neoliberal positions. Computational social science, to a certain degree, is becoming like neoclassical economics in that it's very connected to Google, Meta, these large companies, and their way of reducing and their political interests in the world, and their sort of interest in data collection, reducing human behavior to something that can be captured fully with simple models. What I'm pushing for in that article is to instead study the social world using computational methods, but in a way that's integrated with traditional social scientific theory and that tries to build a sort of critical understanding, not only trying to predict human behavior, but also really trying to understand it, interpret it, and also critique it, right? That we can not only predict how people will act, but that we can say something normative about how the world could be a better place. Those discussions are still very much in there of around this discipline and trying to define it.
When I think about computer science, sometimes I think of it like a toolbox with tons of good tools in it. Not every tool is right for every situation, but probably we can take that toolbox to many industries and there'll be useful things. What are some of the most useful tools that social scientists take advantage of?
I would say that the way that I understand this process is that there's usually a time lag of a few years of things being developed in computer science and then slowly dribbling down into the social sciences and getting picked up. And then usually it becomes like a hype, for a few years and then it kind of dissipates a little bit again. I think we've seen that with topic modeling, for instance, a few years ago. Suddenly everyone was using topic modeling, myself included. And it was a big hype around the method, and then it kind of died down, and now it's kind of one tool that you can occasionally go to, but you don't see it very much anymore. And then we saw kind of the same thing with word embeddings getting picked up by social scientists. So I would say that there is that kind of dynamics where we unfortunately haven't really seen social scientists building this kind of more sophisticated pipelines and so on, where you can draw from multiple computer science methods to sort of analyze a specific data and ask specific questions, but that it's often has the risk of front loading the method a little bit, and then so we have this method, we have this data, what can we do with it, rather than coming from a sort of, I'm trying to answer this question, for this we need to use this range of methods and combine them in this way to kind of draw this out. Moving towards that more pluralist way of using these methods, I think is what's really interesting. And I think we're kind of gradually seeing that transition now. LLMs, I think, are going to be really interesting in this regard.
Do you happen to recall the first moment you had a direct contact with an LLM, be it ChatGPT or otherwise?
It was just some days after ChatGPT was released. Prior to that, I used a little bit simpler, like earlier versions for some machine learning text analysis projects. But there was this, certainly, I think, as many people experienced it, it was kind of a wow moment of starting up ChatGPT and seeing what it could do, which is also part of what triggered my interest in moving into this and trying to think of how it can be applied as a tool within the social sciences.
Well, there's lots of reasons to be impressed with ChatGPT, of course, but it's not a perfect system. I think everyone's bumped into some situation where it can't quite do what you want, even though maybe 9 out of 10 times it can, or something like this. What gave you the confidence to think it could be useful for practical social science problems?
I think just seeing that it's actually quite good at things that these methods have historically been really bad at. And so that was really the kind of impetus behind my paper looking at this. And I was interested in trying to kind of see where it failed and where it succeeded compared to humans and to specifically human experts. Behind that is that there is a very long literature in the social sciences saying that there's forms of interpretation and analysis, text analysis, that are just not possible to automate, that they're uniquely part of the human realm, and that like machines would never be able to enter this realm. And I've admittedly myself been guilty of kind of making that argument and saying that, like, probably, we will never see, or will take a long time before we see a machine or a tool that's able to carry out this type of interpretation. And so the example would be things like subjective interpretation. So the ability to put yourself in the shoes of someone else and, like, why would this person say this? I focused on a task where we had a kind of a ground truth. So we know what the correct answer is. The focus task was to look at tweets, so single tweets from senators in different countries or parliamentarians in different countries. And then the task was to guess which party they were from. And I look at 11 different countries in the world, and but we can focus more on the US as an example. It's quite a nice task because it has a lot of this. It's a very wide variety of different interpretive skills that are needed to be able to fulfill this task. So it seems like it would be just an easy task, but often it's very implicit. You have to use this kind of subjective interpretation and so on, and to be able to solve this task. And then I compared the capacity of ChatGPT with the ability of human experts, people with PhD in political science, and also with M-Turkers, see how well ChatGPT performed. But also specifically, I was interested in seeing where it failed, where were humans able to do it and the LLM could not.
And having done that process, are there any key weaknesses you can identify where the LLM is consistently underperforming the human experts?
What I found was really quite striking because ChatGPT actually outperformed even the human experts with PhDs in political science, as well as Sam Turkers. It was just way better. And there wasn't really any example of any tweet where the humans were better than the LLM. So I couldn't really look at its weaknesses because it didn't really seem to have any, at least not in the data I looked at. Instead, I had to kind of focus on looking at specific tweets or specific tasks were examples of this type of interpretation that we previously thought were distinctly human abilities. It was really quite interesting. Maybe I can give you like an example. So this is a message that was sent by a US senator within 2 months of the US 2020 election. And the tweet reads, "A friend, a neighbor, a mom who could soon serve on the highest court in the land." So do you think it was sent by a Republican or by a Democrat?
Oh, it's going to come down to a guess for me. I'm going to guess Republican, but I don't have a lot of context clues as to why.
Yeah, no, it's correct. And so this was an example of something using contextual information because it refers to the nomination of Amy Coney Barrett to the Supreme Court. For this one, both the experts and the LLM was correct. So I actually followed up also for the LLM and gave it a sort of follow up question to like, why did you respond this? Can you motivate your answer? It does precisely this. Like this tweet probably refers to the nomination of Amy Coney Barrett to the Supreme Court, and so on, and then motivates that. So it's clearly a Republican. So that one was fairly easy. But another one that was also quite interesting is so the tweet reads, "Down Syndrome Awareness Month to help raise awareness for what it means to have Down syndrome and how individuals with Down syndrome play a vital role in our lives and communities." So do you think it's a Democrat or a Republican?
Well, I'm struggling again, but if anything, I'm going to say Democrat for this one.
So that's also what most human classifiers and also most experts answered. And probably the reason is that, Democrats are associated to supporting minority rights and so on, right? But the LLM in the motivation, so the LLM was correct. It's a Republican. And it's quite interesting the motivation that it gave because it says that actually this is probably like Republicans use Down syndrome as a kind of dog whistle for anti-abortion positions. So the tweet is actually about it's actually referring to like an anti-abortion position. So which is quite interesting to me. Like this really challenges the way that we as social scientists tend to think about these methods, right? Because we tend to think about we try to like the gold standard is human interpretation, and humans are somehow by definition better than any tool at this type of interpretation, and so we need to validate the tools against humans. The more right they are, the better the tool is. But then we find that actually it's better than humans. And so that raises really interesting and kind of difficult questions about, how do we work with these methods? And how do we validate? What does it mean to validate if we can look at the response of the LLM and be like, oh, actually that makes a lot more sense. Like I can see, like I understand, like the LLM is right and I'm wrong. Like it's an interesting, and that's also like something that I was exploring in this the second text, which is this how-to guide and how to use LLM as a social scientist, which is targeted at kind of bachelor students or qualitative researchers that don't have much experience in sort of programming.
Well, a common criticism I hear about large language models is that they're black boxes and we have no clue whatsoever how they work inside. How do you feel about that idea, especially in light of asking why did your model make the decision it made?
Maybe two responses. One is the sort of question of how we think about this method. To some degree, if we think of it as similar to a sort of human student classifier that we've hired and given the task of classifying, these tweet messages that we're trying to code some data from, it's very much the same problem, right? Like they are also humans are also black boxes. We don't know what biases they come with. We do know that they come with a lot of bias, but the difference to a certain degree is that with LLMs, we can move towards a world where we have open access. We have access to the type of data that it was trained on. The models can be open source, and I think that hopefully that's the direction that we will be moving towards. It's clearly not ideal to use kind of ChatGPT for this type of tasks. Like it's not a long-term kind of solution. I think we as researchers, as social scientists, we need our own large language models, and we need to know what data they were trained on. We need to know when changes happen and when they're updated. We need to know that for social science to function and be rigorous. But that being said, I don't think the fact that we don't fully understand what goes on within the model or how it reaches its conclusion, and of course, we don't know that this motivation that the LLM gave, that is the reason that it responded what it responded. We don't know that either, right? We can't assume that. But even so, I think that the models can be extremely powerful and that they can help move towards the more rigorous forms of social science.
Well, you'd mentioned that on this task of interpreting the political alignment of the senator's tweets, ChatGPT was outperforming both the political science experts and the M-Turkers. Could you quantify that a little bit?
It was a major win, I would say. So I don't have the numbers with me right now, unfortunately, but neither of them, of course, reached 100% accuracy because some of the tweets were, here's a picture of my cat, and then of course it's just an impossible task, which was kind of the point. I think that the humans were somewhere around 80%, and then the LLM was somewhere around 93 or something like that, which is a huge difference because those were really the challenging ones to guess right. So it was a quite a big difference in accuracy. And I also looked at the level of sort of bias towards Democrat versus Republican in the answers. And then there was also the LLM was either the same or outperformed the human classifiers in having low levels of bias. I can also say, so I looked at the preprint that's up. This is not included, but I look also across 11 different countries, as I mentioned. It achieves high levels of accuracy in every country, but outside of the US, it's lower than in the US. So the US is the highest level of accuracy, and then it sinks in other countries. And I think the lowest was for Sweden. But Sweden is a tricky one because Swedish politicians are kind of known for not talking about politics on Twitter. There's a kind of a special case. It's mostly food and cat pictures for some reason.
Are there good social science hypotheses for why the US would be more predictable? Are we more divided or just more outspoken?
I mean, there's two possibilities, and probably it's a bit of both. And one would be that the politics in the US is quite polarized, obviously. There are quite strong tensions, and everything is kind of politicized to certain degrees. And the politicians are very conscious of what they write. Everything is kind of checked and marked. And the second one is probably that we know that the LLM, the ChatGPT, is trained mostly on the US English data, right? That's also part of the explanation. And the third addition is that since there's only two parties, it's generally makes it a lot easier than guessing which in a multi-party system
Hmm.
guessing the party. So it's just a harder task.
Before reading your paper, I would not have guessed that ChatGPT would outperform the PhD political science students. But I think you established that case fairly well. From like a very humble scientist point of view, we would only say, okay, it's good at this one problem. But it seems to me we could inference from this it's good at other problems as well. Are there any maybe low hanging fruit problems or even difficult ones that you think could be taken on next?
I think that there is a whole range. To be honest, there are so many examples of tasks that in the social sciences that are carried out by students classifying large troves of documents. And one example, which I use in this how-to guide that I've released, is the question of populism, which is a great example of something that is very hard to define. And it's this kind of, we know it when we see it, right? Like, and where social scientists have kind of landed on the question of how to define it is this Cosmude has this ideational definition which focuses on it as a form of discourse or like a thin ideology. And so it's this idea that politicians are populists if they talk about we the people, and they separate that as a duality against the elite. That they have this like the people is pure and the elite is pure evil. The definition runs along those lines. Of course, there's like a ton of discussion of exactly how to define it, but then usually the way that it's operationalized is by having usually students read speeches and texts from different politicians and then rank it on the basis of a definition like that. And of course, the result is that the databases are relatively small. It's very hard to do large studies. If you compare different databases that look at the same politicians, you get they don't match very well. You don't get a very good correspondence. And so I felt that was a good example. That's the example I use in this how-to guide for also thinking about, so how do we validate these models and how do we work together with them as social scientists? What I ended up with as a kind of way of working with this is the idea of working with LLM as a collaborator. Because usually in these teams, when you have a group of students that are classifying public speech, just you work together as a team and you check in on each other and you compare notes and you have this kind of, okay, so yeah, you are actually right. You make a good argument that, this politician probably this is more populism than I marked it as. You make a good argument. That you have this kind of discussions back and forth, and you kind of arrive at a definition through that iterative process. The definition and the operationalization are very entangled in a way that I find quite interesting. What I realized around using the LLM for this is that bringing an LLM into the process of being a couple of students or a couple of professors working with classifying or analyzing text documents, and having an LLM in the mix where the LLM is saying, oh, I would actually classify this as a 5 on the populism scale, and this is the reason why. And then you can get this kind of the same effect as with the Down syndrome tweet that, oh yeah, I see what you mean, and this is a good point. And then you can modify definition. And you end up with a definition in natural language that is at the same time an operationalization, because you can give the definition to the LLM, and then it uses that definition to extract the value. And so it becomes a very powerful, rigorous way of using LLMs for studying concept, operationalizing concepts in the social sciences.
Yeah, I think you've built a strong case that social scientists should be looking at these tools, but not every social scientist has a background like yours. Is this a situation where they need to find a computer science collaborator, or can people start to use these tools directly?
So this is one of the things that I find really most interesting and that I'm most excited about when it comes to LLMs, because they are very easy to use. If you compare it to the his previous kind of natural language processing methods and machine learning and so on, you needed to manually classify 10,000 texts, and then you need a computer scientist to help you develop this machine learning algorithm and so on. So you needed a lot of resources. You needed a lot of knowledge of computer science. LLMs are extremely easy to use. And like this how-to guide I provide, it gives you the entire code for doing a social science project on this in Python. You don't need any previous knowledge in computer science or programming. What you do need is a theoretical understanding of the social world. You need to have very clear understanding of concepts. You need to be a good social scientist, basically. What LLMs bring is really a shift in the balance from the sort of importance of technical skills to be a good social scientist, to be a good computational social scientist at least, to an emphasis on theoretical skills, the classical sort of qualitative skills, such as the skills that social scientists have always been focused on, right? Like qualitative social scientific skills. I find that very exciting to see how qualitative social scientists will make use of these methods to better understand the social world.
Well, for listeners who haven't tried yet, let's assume they've got just basic Python or R experience. They can kind of stumble through it, copy and paste a little bit. Can a person like that get on board with one of these APIs?
For sure. I mean, and now we're talking in a time where we haven't yet seen an easy sort of GUI, easy application that interfaces with the API. So we still have to do some level of programming. But even now, it's easy enough that you can do it without any programming skills. I mean, especially since you
Yeah.
have ChatGPT to ask if you run into any problems.
Yeah.
But this is precisely the sort of aim with this guide that I provide. I provide the entire explanation and like a how-to guide, the full source code. Of course, it's kind of targeted to a certain project. Like you're trying to operationalize a concept and measure it in text, but that's already quite an important starting point. And then you can kind of maybe learn a little bit more, and you can make additions to it if you have a specific question that you want to answer and that moves beyond that.
We're going to include the paper and your Jupyter notebook in the show notes. Well, both papers we discussed, but I think the Jupyter notebook in particular will get people up and running almost immediately. That's not the technical challenge, but maybe it unlocks the next challenge, which is what do I do with the model? How do I write a good prompt? Do you have any prompt engineering advice?
For me, it's kind of what I mentioned before, and that I think of the prompt engineering as it has to be an iterative process of going back and forth and trying to really capture this concept that you're trying to measure. My prompt engineering suggestion would be to develop a sort of process for working together with the LLM and a group of experts and trying to capture a certain concept, and then have it motivate its responses and then compare that with your own notes. So basically, you have a certain goal that you have a certain concept that you want to measure. As an expert, you come with the same prompt, the same definition as the LLM was given, and you do your best in trying to measure these different a sample of different texts, and then you compare where your answers were different from the LLM, and you look self-critically and you think about what was my motivation, what is the LLM's motivation, and if you find that no, I was right, the LLM is wrong, then it raises the question, how do you modify the prompt so that it better captures your understanding, because you had a different understanding from the prompt, and usually it can be quite clear, like how you need to modify the definition to better capture that. For instance, you can add an example, like if this shows up, that is not an example of populism, which is implicit, like, because often in these definitions we have things that are implicit because we are, as social scientists, we have all of this understanding, right? But we need to tell the LLM all of those. And of course, any good social scientific definition also need to include those. That type of iterative process of identifying where you disagree, modifying the LLM's definition, or maybe modifying your own understanding, I find is really helpful for developing this form of prompts.
Well, a quick history lesson. Maybe you know the story of the four coloring problem, but I'll share it with for listeners who don't. It was some time ago. It was a proof in computer science that you could color a tiling a certain way with only four colors. And there was a little bit of controversy around the proof because it was proved with a computer program that checked every possible solution rather than deriving like a beautiful geometry proof from start to finish. I don't think it's so controversial anymore, but at the time it was. That's certainly a new style of proving things. It seems like using an LLM in this way is a very new style of exploration in social science. Is there any controversy with accepting these methods in your field?
I mean, it's so recent that we haven't really seen these sort of epistemological battles play out yet. But I'm absolutely certain that there will be a lot of controversy around it. Understandably so, right? Especially now when we're in a situation where these LLMs that we're using are mostly run by these big corporations that are pursuing their own interests. They are doing various things with the models that we don't actually know because it's all secret and black box. And of course, that is a huge issue. And I don't condone continuing like that. Like, we do need our own models that we have more control over, and it will be an interesting challenge of institution building to try to see how we, as social scientists, as researchers, can construct those models and run them in a way that works. But I think that there's also very interesting kind of philosophical questions around what it means to interpret something, and what happens to the sort of boundaries between the traditional division between the qualitative and quantitative text research or social scientific research. Those divisions are really being challenged by the LLM, which I think is very productive, but it's also sure to stir up a lot of controversy and debate. Hopefully, productive and interesting debate.
If I want to frame it in the worst light, I would say that these are nothing more than next word prediction systems with a Silicon Valley bias. I guess in that harsh light, how would you respond to the criticism?
I mean, to a certain degree, I think it's fair, but I think some of my students could be described similarly. So it is true that we need to be very aware of the sort of biases, but I think it's also very clear that these methods have extremely impressive capacities in moving beyond the sort of previous impasses when it comes to analyzing text data. It will be very interesting to see what we can do with that and how that will bring and push the field forward. For sure, I think we need to be very aware and critical of these biases and of how we use these methods. And also, in some degree, especially since the methods can at times be more powerful than we are. And that creates this tricky situation where, well, how do we know what is bias, and like how does bias show up in that kind of situation? So it for sure, there's a lot of really tricky questions around how we use these methods, and it will be a big debate around this, but I'm still excited about it, and I'm excited to be part of that debate as well.
Well, as the debate is going on, do you think we're going to have a higher, lower, or the same demand for human annotators?
To a certain degree, we've seen a large demand on human annotation from these models, right, and training these models. So that's for sure one source. But I do think that in social scientific projects, this will reduce the need for human annotators when it comes to text as data projects, which I think is it's I'm kind of looking forward to it to a certain degree because it's running these large projects, getting funding and for the research, and it's really hard work, and it really limits the amount of research that is being done using this type of text data, using text data for analysis, and it also directs the research to focus on not always the most productive venues. So, for instance, we've had so much research on social network analysis, which I think is great and very important, but most of it doesn't take into account like the content or the nature of the interaction. So there's so much research looking at mention networks on Twitter, for instance, because it's so easy to get. At the same time, we know that mentions can mean absolutely anything. Like it can be a criticism, it can be positive, it can be negative, it can be like a whole range of things. But we rarely look at that because it's just very costly to do so. It's interesting in that way, that LLMs open up a whole range of research that is easy to do, and so we will see a lot of interesting things being developed because of that.
What's next for you in your research?
I'm currently in a project where I'm looking at how LLMs can be combined with agent-based modeling, which I find is a really interesting venue for this as well. So this kind of comes from, agent-based modeling is when you maybe I can say a little bit about it. Is when you create a number of kind of agents representing humans usually, and they interact in kind of simple rule-based ways. Then you have some unexpected pattern emerging from that. So it's this understanding of society as a form of complex system. A classic example would be like the Thomas Schelling segregation model from 1971, where he showed that high levels of segregation can emerge in a system, even though all the individuals prefer an integrated state and they have only a slight bias towards having homogeneous neighbors. You can get a kind of feedback effect that results in very high levels of segregation. And so it comes from this kind of, to a certain degree, natural science metaphors applied in the social world, kind of particle physics and so on, that lens of thinking about society. And it's been in some ways, very productive model. But I think for me as a social scientist, it misses also the kind of point about what the social world is, right? Because the social world is all about interpretation. There's this great quote from the Nobel laureate Murray Gell-Mann, who said that, think of how hard physics would be if particles could think. And that is precisely the situation that we're in as social scientists, right? Because our particles are thinking and they are reasoning and they're reacting to each other. And that is really a space where we haven't had any types of models to capture that, to capture the kind of reasoning and meaning making and how agents or humans are interacting and making sense together, and how that leads to this kind of its own form of emergence, its own form of complexity that is distinctly social. And so that's really a space that I find in some way epistemologically very interesting to explore, of how combining large language models with agent-based modeling can allow us to explore these types of complexity that is really at the heart of society.
Do you have any advice for students, be they grad students or undergrads? I mean, there was a time when a big part of grad school might have been labeling documents, and probably that's going to evolve. Any advice for an academician working their way through the system as technology evolves?
I think that to a certain degree, because my advice for a long time would have been something like, you need to know computer science, you need to know programming, you need to be able to use, these sophisticated tools. Now, to a certain degree, I think that the LLMs is also increasingly opening the path for just having a very deep qualitative and conceptual understanding of the social world, and yet being able to use these methods in interesting ways. And I think it's such an exciting time to be in social science, because it's such an open field to a certain degree of using these methods and coming up with new ways of how they can be applied to understand the social world. Being part of that space and exploring how these methods can be used, I think, is a great place to be as a social scientist right now.
And Petter, is there anywhere your listeners can follow you online?
So you can find me on Twitter, Petter Thornberg. I'm also on ResearchGate and Google Scholar and the usual ones.
Cool. Well, we'll have links to all the above in the show notes. Thank you so much for taking the time to come on and share your work.
Thank you. That was a lot of fun.